In this video, we will be discussing about basic data types, and few of the basic data types in Python are integer, string, float and boolean. Now let's get started with integer data type. So what is integer data type? Integer, as we all know, that it is a whole number and which doesn't contain a decimal or a floating data type. And we have few of the integer data types like hexadecimal, binary and octal. What we are using in our daily life is a decimal data type. Clear? That is, it may be a floating or it may be a pure integer, it doesn't matter. But we are using decimal data types. But the problem is Python or the computer doesn't understand. So in such case, they will communicate via these data types like hexadecimal, binary or octal. And whenever you want to convert this binary to octal or hexadecimal to octal, you have to always write the prefix and then followed with the specific binary code or a octal code. Clear? The prefix for binary data type is 0 bit, maybe uppercase or lowercase b. Similarly for octal, it is uppercase or uppercase or lowercase o. And for hexadecimal, it is 0 x. It may be uppercase or lowercase x. Now let's get started with binary data type. So what is binary? Binary is just a way of writing numbers to computers. Just how we write all the instructions in a high level language. Similarly, binary is just a way of writing numbers using zeros and ones so that computer understands. Because computer understands only machine level language. Clear? And each digit in a binary, it represents a bit. Here we are seeing example of binary is 0101. So every digit like 0, 1, all these represents a bit. Each bit represents power of 2. And here we are seeing 8421. This 8421 refers to weights of each binary digit. In a 4-bit binary system, currently we are talking about 4-digit binary system. And we have to always read this from right to left, especially while we are calculating any binary number to decimal number conversion. Here, so let's see how it works. As I mentioned, each bit represents a power of 2. Take an example of 0101. Here 2 power, this is a bit position and they are representing power of 2, and whenever I want to convert binary number to an integer number or a decimal number, I have to multiply each bit by by its weight. By its weight or by the bit position, anything is fine, because even if I multiply with weight or if I multiply with the bit position, I get the same result. Clear? So 2 power 0 is 1, 2 power 1 is 2, 2 power 2 is 4 and 2 power 3 is 8. Now take an example of 0101 in binary. So I want to convert this to a decimal integer, sorry, decimal data type, and the decimal data type for this is 5. Now how to convert this? So what I'll do, I'll take bit position and the weight value, I'll write it as it is. Now to convert this, make a note of all the binary digits 0101 from left to right, sorry, from right to left. Here we are seeing it is 1010, and these must be mapped to certain weight value and bit position. Clear? All these binary digits must be mapped to weight value and bit position, and you have to follow from right to left, not from left to right. Clear? Now what I'll do, as I mentioned, the bit need to be multiplied by its weight position. Now the bit is 1. I am multiplying 1 with the weight value, that is 1. So 1 into 1 is 0. Even you can multiply using the bit position, that is bit position is 2 power 0, right? So 1 into 2 power 0. So 2 power 0 is again 1. So it is 1. Both are same. Either you multiply with the bit position or with the weight value. So both are same. Similarly, 0 into 2. If I just multiply with 0 into 2 power 1, it is again the same. So 0 into 2 power 1, which is 2. So finally it is 0. Now the third bit, that is 1 into 4 or 1 into 2 power 2 is 4. And next 0 into 8 is 0. Now what you will do, you have to add from left to right. For calculation, you have to calculate from right to left. Final sum should be from left to right. So 0 plus 4 plus 0 plus 1. The final answer is 5. Finally, we converted a decimal number to a finally we converted a binary number to a decimal number. This is how it works. Take an example of 1110. This is a binary number and I don't know the decimal. So what I'll do, I'll make a note of this. Now I want to convert 1110 to decimal, but I don't know the decimal value. So what I'll do, I'll try converting this. Clear? So 2 power, so 0, my first step will be 0 into 2 power 0. What is 2 power 0? 2 power 0 is 1 plus 1 into 2 power 1. 2 power 1 is again 2. Clear? And next bit what we have? 1 into 2 power 2. 2 power 2 is 4. Hope you are getting what I am trying to do here. And next the last bit what we have? 1. 1 into 2 power 3. 2 power 3 means 8. Now what I'll do? I'll try to do the sum of all these. It is 8 plus 4 plus 8 plus 4 plus 2 plus 0. So what is the final answer? It is 14. So finally the converted binary number to decimal number is 14 and the binary number is 1110. This is how it works. And you have to always follow the calculation from right to left. Yes. Now let's move on to VS Code and execute few of the examples. Now here they have already mentioned few of the examples. Here it is a equal to 0 1. Let's uncomment everything. It will be clear for you to understand. So in the first example, as I mentioned, we have to always follow the rules. That is 0 followed by, it may be either uppercase B or lowercase b, followed by any of the number in binary. So let's take an example of 1. Now when I try to print A, then this will print the digit in decimal. Sorry, this will print the digit in either integer or a decimal. Clear? So here it is 1. Similarly, when I try to take any other example like 1110 as we have seen now. So from the calculation what we got, the decimal value for this is 14. So here it is. So the calculated value also remains same, 14. Similarly, any other example like yeah, 111. Print C. It is 7. Yes. And take an example of this. Print D and this will print 16. Right? And for 15 it is 1111. You have to, the prefix I missed out. Print E. 15. Right? So this is how it works. So this is all about binary number. So this is all about binary data type. So in the next video, we will see how to convert a integer to a hexadecimal and octadecimal and vice versa. Till then, take care. Bye bye.